Have you ever wondered what it would be like to see inside the human body? I mean, with stunning, crystal clear detail, but without using any harmful radiation at all? It might sound like something straight out of science fiction, but it's a reality that doctors use every single day.
So that's the big question we're tackling today. How is it even possible to get these unbelievable pictures of our organs and tissues without a single cut and without any of the risks that come with radiation? Well, the answer is a truly revolutionary technology, and we're going to break down exactly how it works.
All right, so for this explainer, we're going to take a four-part journey. First, we'll open up a window into the body. Then, we'll get into the really cool part, what I like to call the dance of the atoms. After that, we'll see how doctors actually decode the images. And finally, we'll talk about safety and look at what's next for this amazing tech.
So let's jump right in with Part 1, a window into the body. This is where we'll unpack the fundamental power of non-invasive imaging. Okay, so at its core, magnetic resonance imaging, or MRI for short, is a medical technique that really just uses two key ingredients: a super powerful magnetic field and radio waves. That's it. Together, they create these incredibly detailed pictures. No scalpels, no X-rays, just magnets and radio frequencies.
And this comparison right here, this gets to the heart of what makes MRI so special. Things like X-rays and CT scans are fantastic tools, but they use what's called ionizing radiation. MRI, on the other hand, doesn't. And that is a massive advantage, making it an exceptionally safe way to see what's going on inside of us.
So, you might be asking, if it's not using radiation, then how in the world does it work? That question takes us deep, deep into the microscopic world in Section 2, the dance of the atoms. This is where we uncover the secret behind those incredibly detailed images. It's pretty cool.
So, what's the magic ingredient inside of us that MRI takes advantage of? Well, it's something our bodies are absolutely full of: hydrogen atoms. We have billions of them, mostly from all the water in our bodies. And these tiny little atoms, they're the key to the whole entire process.
So, how does this atomic dance actually work? Well, it happens in four main steps. First, when you're inside that powerful magnetic field of the MRI machine, all those hydrogen atoms in your body, they suddenly snap to attention, and they all line up, kind of like tiny compass needles. Then, step 2, a quick pulse of radio waves comes in and knocks them all out of alignment. And here's the crucial part, step 3. As they relax and snap back into alignment with the magnetic field, they release a tiny, tiny signal. And finally, a computer listens for these millions and millions of signals and translates them all into that detailed image that the doctor gets to see. Okay, so we've got the signals from the atoms, but how does all that, atomic noise become a clear diagnosis? That brings us to part 3, decoding the images, where that raw data gets translated into life-saving medical information. And this is where the real artistry of MRI comes in. See, different types of tissues release their signals at different rates, and technicians can actually tune the MRI to listen for specific signals. Think of it like using different filters on a camera. A T1 sequence, for example, is like a sharp anatomical filter. It's great for seeing solid structures. A T2 sequence, on the other hand, makes anything with fluid, like inflammation or a cyst, glow really brightly. And then you have specialized sequences like STIR, which can zero in on things like swelling or muscle injuries. It's this ability to switch between filters that gives doctors such a complete picture. And because it's so versatile, the clinical applications are just incredibly wide-ranging. We're talking about everything from mapping neurological diseases like MS, to spotting tiny tears in an athlete's knee, to monitoring heart function, and even detecting cancers at their earliest stages. MRI gives doctors this unparalleled view to not only diagnose problems, but to also check in and make sure a treatment is actually working. This brings us to our final section, safety and new horizons. So here we're going to touch on the absolutely critical patient protocols. And then we're going to look into the really exciting future of imaging. Now, while MRI avoids radiation, you have to have a ton of respect for its own power source, that magnet. It is incredibly strong, strong enough to pull large metal objects right across a room. And that's why this safety rule is completely non-negotiable. All metal has to be removed, and patients are screened very carefully for things like pacemakers or certain implants that could be affected. These strict protocols are there for one reason: to protect everyone. And this technology is evolving at an incredible pace. We're already seeing the next generation of imaging in action. Functional MRI, or fMRI, can literally watch your brain think by tracking blood flow in real time. It's amazing. Cardiac MRI can create moving videos of your beating heart, and whole-body MRI is becoming this powerful tool for screening for cancer, offering a complete look in just a single scan. The possibilities are just constantly expanding. Which really just leaves us with one final, thought-provoking question. I mean, think about it. We've gone from blurry X-rays to literally seeing the function of our brains in real time. If we can already see inside ourselves with this much clarity today, just imagine. What secrets will the future of this technology reveal tomorrow?